Okay guys, today's lesson video is going to be on how to find the volume of a cylinder. Okay, lesson title, let me get a pen here that will write. Lesson title is going to be volume of cylinders. Now, today should be April the 27th. Alright, so last week we talked about how to find the volume of prisms, like boxes and triangular prisms. And the formula that we really focused all of our attention on was volume equals to capital B little h. Okay, again, volume is how much something holds, and this formula will give you the amount that something will hold. Capital B is going to be the area of that shape's base. Okay, the base area. H is going to be the height of that shape. Now, if we transfer this formula over to a cylinder, by the way, in case you're not familiar with what I'm talking about with a cylinder is like a Pepsi can. Okay, it's round, it's a circle on the top and bottom, and it's connected with a rectangle. So, I'm talking about this shape right here. There's a circle on the top. There's a congruent circle on the bottom. That means it's the same shape and same size, right? So that's a cylinder. I mean, there are different size cylinders, but they all basically have the same shape. They have two identical circles that are parallel with each other, right? There's my parallel circles. Those red circles, they're the same size. They're the top and bottom of the cylinder. This is the base of the shape, right? It's a circle. The height of the shape is going to be how far the circles are apart. So if I want to find the volume of this Pepsi can, if this is a Pepsi can, what I have to do is find the area of the base circle, and multiply that times the height of the can, which means the volume of a cylinder is found with the formula V equals area of a circle, so pi times r, right? That's the area of a circle, times the height of the can, h. So pi r h, right? R stands for the radius. Look, y'all just took a quiz for me last week. Some of you did not do well on determining when to use radius and when to use diameters of circles. Radius is always halfway across the circle, period, always. And we always use radius. I'm never going to use a formula in the 8th grade that asks you to use a diameter. So always get the halfway across the circle distance, which is the radius, right? So let's go in and work a couple of these problems of different cylinders. So again, hopefully you're copying my notes. I just don't think any of you can just watch this and get it. I think you need to write it down, have it in your notebook, and study it. Hopefully you're sitting here with headphones on so you're not distracted. You can really listen closely to the notes. So here's our can. It's not a really neat can, but I'm doing the best I can on it. So let's say that we have a radius on the bottom. Let's say it's 3 inches. And let's say that we have a height on the side that's maybe 5 inches. Okay, and I want the volume of the can. So the volume of this can is pi r r h. Remember, pi r r stands for capital B because that's the area of the base. So this is pi r r times the height. So in our problem, remember, pi is going to be 3.14, not the pi button on the calculator, but 3.14. Radius is halfway across circles, so you have to ask yourself, did they give me the radius or did they give me the diameter? In this problem, they gave me the radius halfway across, which is perfect. That's what I want. So I'm going to use 3 times 3 times the height of the whole thing's 5, right? Once you write all this down, you grab your calculator. By the way, the homework checks, the things I'm seeing, I'm not seeing. When I say show the work, this is the work right here, okay? I need to see that written out. Some of you just want to grab a calculator and type it in and get an answer, but I still want you to write out the numbers in the formula. So on my calculator, I have 3.14 times 3 times 3 times 5. And I'm getting 141.3. So 141.3 is the volume. Now, if we're talking about inches, remember what volume is number of cubic inches, cubic meters, cubic yards, cubic miles, cubic whatever your unit of measure is. Mine's inches. So this would be cubic inches. A cubic inch is like a dice. So this is how many dice would fit, or die would fit inside of this can. Well, I mean, you can't fit dice in a can, right? So what you could do is fill up 141.3 dice full of water and pour that water in this can. That's how much it would hold, right? Think of it that way. So that's one example. Let's do another example. This time, we'll take our cylinder and we'll lay it on its side just so it looks different. So we'll have a circle here, and we'll have that same congruent circle back here. So this shape to me is supposed to resemble more like a straw, right? Think of a drinking straw, or maybe a piece of pipe that a plumber would use or something, right? So let's say that it's 2 foot long. So this is a piece of pipe the plumber uses, and let's say that it has a diameter all the way across of 0.75 feet. Okay, so not quite 1 foot. All right, so we got some work to do here. I want to find the volume of the pipe. The volume of the pipe is a cylinder, so it's still pi RRH. In order to find the area of the circle, I need the radius. I don't have the radius, right? The radius would be half of this black line, right? So I need half of it. So the first thing I do on my calculator is go 0.75 divided by 2, and that'll give me the radius number. So 0.75 divided by 2 on my calculator equals to 0.375. So the radius, the red line, is 0.375. So I'm going to type in all my decimals now. 3.14. I know the radius is 0.375. I have to write that twice. All right. Times the height. This is what confuses people. The height of this cylinder, the height of this can, the height of this pipe is actually this blue line on the bottom. It's the distance between the front and back circles. So the height of this pipe is actually 2 foot. It's not the distance up and down. It's always the distance between the 2 circles. So my height here is going to be a 2. So all the numbers in red here deal with the circle. Right, pi RR. And then the number that's in blue is the height of the cylinder. We're going to type all that in the calculator now, right? So I'm going 3.14 times 0.375 times another 0.375 times a 2. We're going to have a long, messy decimal. It's a small amount. So this equals to a 0.883125. Okay, so it's just a terrible number, but it's the right answer. If you want to round this, I'd love you to round it to 0.88. I know some of you may even round this to just 0.9, which is okay, right? I like this answer a little better, but I think your book has you round everything to nearest tenth, so I'm good to round this to just 9/10 of a cubic foot is how much water it would actually hold. Okay. All right. Let's look at another one of these problems that's different. I don't know this is going to be hard for you guys to copy. I hope that you can kind of see what I'm trying to draw here. I'm going to draw a shape, and I'll see if you can figure out what it is I'm trying to draw. Okay, there's my shape. So when I ask people what that looks like, a lot of people would normally say it looks like a loaf of bread or maybe a mailbox. Okay, that's the two things I get, which is both, they're both correct. Okay, they're both correct. I want to find the volume of the shape. This is a compound figure, which means it's made up of two shapes that we're familiar with. If you take your pencil, or at least, can imagine cutting this thing right here and cutting it right here, right? We have two shapes. I'm going to take this apart and show you the shapes. All right, on the bottom, I have this shape right here, which is just our little regular prism box, right? And on the top, we have this shape, which is, I hope you see this as half of a cylinder, okay? It's pretty hard to draw this stuff. I've done it for a long time, so it's a little easier for me. I'm still not perfect and neat as it needs to be. Considering this tablet I'm working on, that's about the best I can give you. So we're trying to find the volume of this, and I've kind of give you a hint on what we're doing. We want to find the volume of the box right here and add it to the volume of the half cylinder that's on top. So this is a combination problem where you have to add two things together. So let me give you some numbers here. Let's say that this is, we'll just do like a regular mailbox. We'll say this is 8 inches across here. We'll say it's 8 inches from here to here. Say the mailbox maybe 16, 18 inches deep. So we'll say 16 inches from here to here. I think that's all that we need. Okay. Now, let's go back up to our little pictures and see if we can transfer some measurements over here so we know how big this box and half cylinder is. If we look at just our box, if I transfer these measurements, okay, this is an 8 and a 16, and the back is also an 8, right? Well, that's an easy one. The volume of our boxes is equal to length times width times height. So go to your calculators, 8 times 16 times 8, and let's see what that equals. I got 1,024. All right. Okay. Now for the half cylinder, you're going to find the volume of the whole cylinder and just divide it by 2. So the volume of this cylinder is going to be volume equals pi r r h, right? In order to do the volume of the cylinder, we need the radius. Okay, I didn't give you any numbers up here in the picture on this cylinder, so you got to get them all from the box. So if we look at the cylinder, I think this red line on this cylinder is the same as this line on the box, which means it's 8. Okay, but 8 is not the radius of the circle. 8 is the diameter. I need the blue line here, which is half of that. So 8 divided by 2 would be 4. So I need 3.14 times 4 times 4. Now, I need the height of that cylinder. Remember, the height of the cylinder is how far it is from the front circle to the back circle. That's this distance right here. If I go back to the box, that would be this distance right here, which has to match that number, so 16. All right, type all this in the calculator. Mine's giving me 8 0.03.84. Now, don't forget, that's the volume of the whole cylinder. We only have half of the cylinder. So now was the time that we want to take this number and divide it by 2. So while it's on your calculator and you're looking at it, just hit divided by 2, and we get a 401.92. Alright, this is the volume of the half cylinder. We already know the volume of the box. Just add those two together. So this becomes a 1425.92 answer. Right? Alright, so you're going to need to look at this one a couple of times, these videos. Again, the main thing about today is we're looking at volumes of cylinders. And cylinders are just circles times the height, right? Pi r times h. So we have a can times how tall it is. Make sure you're using the radius all the way through, okay? So just go back through here, look at this video a couple of times, click back through the screens, use the right formula and give it a try. I think for today, you're supposed to be working on that worksheet that you guys had last week. It's still uploaded. You can find it. But it's the worksheet, page 338 that I gave you last week. We didn't do the whole page. We just did some problems with the boxes. But today you're going to be working on the problems 12 and 13, 16 and 20 and 21. Okay, it's only 5 problems. Try these 5s today. We'll check them. I'll have a video up for you to check it tomorrow, and we'll see if you're right. Okay? All right.